Okay, so today class is about using loan data from Kaggle. This is the publicly available data. What we are going to do, we want to check when some people get approved or disapproved for loans based on their characteristics. So today, again, for today project, I put all the instructions on the PDF file. You can take notes, but don't worry if you miss some parts, because as I usually do, I put all the instructions on the PDF file. In addition, I'm going to also record today's session because I think it might be beneficial for your final project. I'll give you a few more minutes for everyone to import the workflow into the Knime, download the files, and be ready for today's class. So let's look at the data set. So it includes the person education, gender, employment, the purpose of loan, different rates, eventually if somebody gets approved or not. So the AI model that we are gonna see today reads the historical data, and then when somebody gets approved and not approved. Do you guys remember an example we had in some classes before, some weeks ago? So it's like loan is something like credit card applications. Do you guys remember we had an issue with using AI for investigating if somebody qualified with different credit limits? Do you guys remember? What was that?
No, I don't remember that much, but I remember we did it.
Okay, the company was Apple, right? And Steve Wozniak had the issue. Actually, his wife had the issue, right?
Oh yes, Glenn had an issue, and I mean, like they contacted Apple, but they treated him just like an ordinary customer in that whole case.
Okay, so
yeah,
prioritized Wozniak because he was a male figure.
Yeah, and also he had a lot of income.
Was a female.
Correct. So we had an AI model. That case was the Apple credit card, and that one was biased against female. So they saw that every characteristic is same between Steve Wozniak and his wife, but his wife got 10 times less credit in comparison to her husband. So we had the bias issue. So as I said, one reason could be that you don't have a balanced data set. So for today's class, we're also going to address biasness and also balance in the data in different aspects. But in addition to that, we want also check generalization of our model, which means we also do cross-validation, see if our model is enough reliable for future use. Okay, before starting the project, any question from previous classes related to AI modeling? Okay, so the workflow that we are going to see today has 3 sections: data preparation and feature selection, model training, and also cross-validation. Okay, so click on CSV Reader, the first module. When you open it, you can see it has an address on my system, right? And if you check the address, is a folder that has loan data on my PC. just change the address, click on Browse button, and find where you downloaded the loan data.csv. So if you want to do that, just click on Browse and say, find where did you download the CSV file. Even if you don't have to actually find the file for today if you just want to see. But if you want to do some changes on the workflow, you need to find where did you download to be able to run the workflow on your PC. In case you have questions, you can just raise your hand and I check your PCs. Can anyone tell me this is a regression model or classification one? What's the target variable is somebody can get a loan or cannot get a loan. Classification, correct. So your target variable in Knime, actually we call dependent variable target variable, so it's a Knime jargon, but in here is a label or a class of dependent variable, which if somebody gets approved or got rejected. So although if you check the dependent variable here, which is 0 or 1, so loan status means 1 means somebody got approved, 0 means got rejected. This is it's not the number. So we are not doing regression. This is a classification. 0 here means rejection, 1 means acceptance. Okay. There is a rule of thumb, or I can say general rule, that inputs of statistical models and also AI model must be numeric, except for target or dependent variable that in some problems could be a label or a class. Look at here. So rental situation, education level, gender, and there are other variables are string or categorical variables. You cannot put them into AI model. You need to convert them into a numeric equivalent. So there's some catch in some Python or R libraries and also some Knime nodes. You still can't have categorical input or non-numeric inputs. Those nodes or libraries convert them by themselves. But this is not a good practice because it's not everywhere. So what we do here, we do conversion by ourselves. We don't rely on Knime nodes to be able to do it by themselves. Okay, so next part of this project, the workflow, is encoding. So encoding means converting non-numeric values into numeric equivalents. So also I want to let Knime knows that although my dependent variable is 0 or 1, they are not numbers. They are actually different labels. So click on number to string and get to the settings. I tell you the loan status should convert from numeric to a string. So my Knime workflow would understand I'm not doing regression, I'm doing a classification. Because 0, 1 doesn't mean anything except for label of either acceptance or loan rejections. The next two part of this encoding meta node is for converting my independent categorical variables into numeric. You can do different methods. One is one-hot encoding, another one is label encoding. In statistics, you just have one-hot encoding, but in machine learning, you also can do label encoding. Label encoding is easier one. What you do, you assign a number for each category. For example, for category of gender, I assign 0 to female, 1 to male. Type of loan, I assign 1 to other, 2 to rent, 3 mortgage, 4 to own, and same for the others. So basically, in label encoding, you just assign a number. So let's just click on the first one and get to the settings. So the first one is related to person home ownership. I'm just saying that I start from 1, and the next label increment by 1 will be incremented by 1. So the labels would 1, 2, 3, 4. Okay. As you see, for label encoding, I have 2 types of nodes. The yellow one and also green one. Both of them are correct. Yellow one does numbering automatically. The green one, you have more adjustment in which you can put your own numbers. For example, let's click on the last one. So I'm saying that intention for loan, if it's education, assign number 2, venture 3, personal 4, medical 5, and next for the others. I give you a few minutes to, if you want to put some comments. So again, the purpose of this part of workflow is converting non-numeric values to numeric equivalent, right? We have 2 ways we can do. One is one-hot encoding. The next one, label encoding. First, I'm going to explain the label encoding. So in the label encoding, you just assign a number to each category. With category to number node, it does it automatically. With rule engine node, you can just do it by yourself. You assign a specific number by yourself. It doesn't need to be 1, 2, 3, 4. It could be 4, 5, 6, 7, or anything. Again, let me go over the PDF file. So I sent, for this data preparation part, explain the reason why we do encoding. But again, I think also it's a good practice if you put your own comments on each part of the workflow. Have you ever had one-hot encoding in your other courses? Even MSBA student, right? Okay. But you got the purpose, right? So you cannot put non-numeric values into machine learning models. Okay. So If you open the one-to-many node, let's click on it. Okay. So I'm just saying that look at the person education, and for each level of education, create a dummy variable. So let's say Faraz is is it your second master or his first master?
My first master.
Oh, so you have an undergrad, so it's UG. I think I met one who had more than one master. Is there anyone in class that already has a master degree? You okay? What's your first name? Lee. Is it correct?
Yeah.
So she has a master degree, and I have a doctorate degree. Okay. Again, these are not numerical values. I cannot put it in the model, and I can't use it. I cannot use it directly for evaluating which one should get some certain credit limit or loans. So in one hot encoding, for each level of education, we create a dummy variable. For example, for high school, then undergrad, master, and doctorate. Okay? Dummy variable means either 0 or 1. So Faraz has an undergrad degree. I put 1. So he's not high school, he's not master, he's not doctor. For Lee, she already has a master degree. So high school, undergrad 0, master 1, doctorate 0. For Hamid, 0, 0, 0. So using this method, I converted a non-numeric column into equivalent numerics. Let's do what happens if you do label encoding. In label encoding, I assign a number to each category. So high school maybe 1, 2, 3, and 4. So Faraz would be Faraz, what will be your equivalent numeric if you do label encoding? You're not high school. 2, right? What about you? What 3? And I would be 4. Okay. So 2 different methods. One hot encoding, you make multiple dummy variables. In label encoding, you assign a number to each category. Again, the purpose is converting non-numeric variable or column into equivalent numerics. Okay, so there is also something interesting to know. You don't have. What's your question?
I think, like, another thing I wanted to add is, like, I remember back in the day when I was working with JavaScript a few years back, I think, like, we can convert each letter over there, like, using code into specific characters as well, right? As well as using the code as well, right?
You can do conversion to any number, but number, not characters.
Yeah, and also we can get, like, that. We can name it according to different states as well, right? I don't remember that much, but I remember a way.
It should be a way, yeah. Again, it doesn't need to be 1, 2, 3. You can say 100, maybe 300, 400, 800. Whatever. Just a number. So you might say there is the ASCII code which you can.
That's what I wanted to say.
ASCII.
Yeah.
Okay, ASCII. Maybe you count ASCII of U plus it ASCII of G, and you find what's the overall summation. That could work too. But again, you should have a logic, a specific logic how to do the conversion. There is also one point. Do you think if I just exclude the UG column, which is for undergrad, can I still understand what's the latest degree of cutoff? Why? Look, you are not high school, you are not master, you are not doctor. What would be your degree?
Nothing, right? There's no undergraduate.
So there is, okay, so there is only 4 level of education: high school, undergrad, master, and doctorate. You're not high school, you're not masterate, and you're not doctorate. Those are the only ones.
There'll be UG, but there's no UG column over there, right?
Doesn't need to be, because with these 3, I can't understand what would be your degree.
Nothing.
You are still a human. If I exclude this one, right?
Yeah, if there's no entry.
Oh, we could have an uneducated column too. But my point is, you always you can drop one of the columns. Yeah, you said your friend said maybe somebody is not educated. Okay, so you can still have uneducated column. For example, UN and Faraz still would be 0 here, 0, 0. Right?
So it will be like implied in a way.
Yeah.
It will be implied in a way that I haven't undergraduate degree, but there's no column over there.
Then you already know you're not uneducated, you're not high school, you're not master, you're not doctorate. What would be your degree?
Yeah, you did no doctor.
I assume you're not a pope, so you're you're the regular education system.
Yeah.
Okay.
Yeah, but the option of UG is gone, right? We removed it.
It's gone, but with this remaining one, I can understand what would be your degree.
There's zeros all over there.
Zeros, but if you're not these 4, your only option will be UG. Yeah. So you might say, why we do this difficulty of dropping one column? So what's the point of that? Do you guys remember overfitting concept? So in overfitting, you fit the model very, very well on training set.
That we are not able to understand.
Yes, you cannot generalize your model. One of the reasons you have too many variables. So usually in machine learning or AI project, we try to drop variables that are not necessary. For example, here UG is not necessary. I cannot drop 2 because even if I, let's say I draw high school. Okay, Taras is not uneducated, is not master, is not doctorate. He could be either uneducated or high school.
Yeah.
So you only can drop one of them. Right?
Yep. But when it comes to like complex data sets where we don't know, there could be another variable as well. So it will be tough to identify which variable it was that we removed, right?
So you only
Everyone
drop
born
when you're 100% sure. Yeah, if you're not sure, you don't do that. But I think you got the point. So look at the education one. So instead of having education column, now I have column for master, high school, bachelor, associate, doctorate level. Okay. I'll convert it to 0 and 1s. Versus, let's click on loan intent. So where did I put that? Personal home ownership. Now, for this case, I have 1, 2, 3, 4. So there's two ways of handling non-numeric columns, either one-hot encoding or label. You don't have to drop one of them, but this is a very common practice. Is the reason I'm showing you here. You have different ways to get rid of unnecessary columns. This is just one of the basic ones, but since this is a very common one, so you might see when people do one-hot encoding, they get rid of one of the dummy variables. So there's no issue, but frankly speaking, is not 100% necessary. we just try to avoid overfitting, and one way is just having least possible amount of numbers. Okay, so let's look at the end of this meta node. Everything is numeric, right? Now it's ready for AI or using any machine learning models that you are aware of that. Okay, so next part is partitioning. So with partitioning, I divide my data set into sections, train and test. With the train, I train my model. In the test section, I evaluate the accuracy of the model. So if you click on partitioning one or just anywhere to the settings, I'm just saying that, okay, 70% for training and remaining for test. And also I use the random seed. Do you guys remember in one of the workflows, when we ran the project, everyone found a different accuracy, right? Because that time we didn't. Okay, now we do the random seed, so all of us should get exactly the same results. Again, randomness in mathematics is real. In computer science, is pseudo-real. It's not exact randomness. If you don't use a random seed, what happens? Computer science algorithm check your computer clock, and they just do some calculation for selecting some observations. But instead of clock time, you use a number. Your computer uses this number for taking some of the observations for training. Questions so far? Okay, by this part, could be very similar, almost, it should be similar to all of your projects. Next part, I'm taking care of imbalancedness. As I said, if your data set is not balanced, you tend to be biased on certain categories. Today, we check the bias against dependent variable. So in maybe next classes, we look at different genders or different ethnicity. But for now, we want to see if for each level of or each class of dependent variable, we have same number of observations. Click on class imbalance and get to inside the meta node. It's a busy meta node, but first of all, look, it has 1, 2, 3 triangle, and I just use the middle one. I propose different methods for avoiding bias. For example, look, the upper one is downsampling, middle one is oversampling, and bottom one synthesized sampling. Before doing that, let's check group by. Just click on it. Can anyone tell me how many people got accepted for the loan by checking the results of group by node? 7,000, correct. How many got rejected? Okay. So if you check here, my data set had 31K observation. Among them, 7,000 got accepted because the value is 1. 24,499 people got rejected. So if I train a model here, since I have more observation for rejection, this model would be much better in predicting rejection cases than acceptance, because number of observation for acceptance is much less. Question at this point? And next classes, we also look at different class of observations. Here, we just look at the dependent variable. We want a model to be good in predicting both acceptance and rejections. But in other workflows, we'll also look at the different ethnicity, different genders, so on and so forth. Okay. For now, we saw that our data set is not balanced, and there is a high probability that we can predict the rejection cases much better than acceptance cases. Okay, so there are different methods to balance your data set. So look at the upper one that I just drafted, but I didn't use it because look, there is no output after the green rectangle, right? So it's downsampling. What does downsampling means? I randomly remove some observations from the data set that I have a high number of observations, and then balance both of them. So we call it downsampling. Click on the group by after downsampling here. Now both of them have 7,000 observations. It may or may not be a performable method, but usually I don't use it because we lose so many observations, we might lose some information. So downsampling, I'm not a fan of that unless you have a very large data set. If you have too many observations, maybe 1 million or 2 million or more than that, you might say, okay, my PC is not enough strong. Maybe I use downsampling because I still have a good amount of observations. The second method, which I built my data set after that, is oversampling. So what does oversampling mean? Instead of reducing one category, I do multiple random copies of observations for the category that I have low number of observations. So and then I would balance my data. So we go inside this green rectangle later on. But look at the group by at the end. Both of them are exactly the same here. What happened, I did multiple random copies for the category that I had lower number of observations. Okay, before going inside the oversampling, let's look at the synthesized oversampling. In synthesized oversampling, I use some sort of mathematical methods or pseudo machine learning algorithm in order to generate new observations. Okay, so if you click on group I, you can see now number of observations, both categories are exactly the same. What happens here? I use mathematics to generate new observations. In oversampling that I did in the middle, I just copy and paste some random observations. So let me see if I can show it some to you. Look at here, the ID column. I have multiple row 48 because I just did multiple copy paste of row 48. So because I wanted to balance the number of observations. So random oversample is just copy and pasting some observations. Mode or synthesized oversampling means using mathematics to generate new observations. Okay, let me just wait a couple of minutes here if you want to write your own notes. Then I go inside the oversampling here. So a cheat, a cheat way for a cheating way for your final projects using this workflow and add your own components, right?
But the thing is, like, if everybody else does that, then there'll be no difference, right?
No, there will be some differences because, for example, some of you over do synthesize learning, some of you do oversampling, downsampling. For let's say, I think one of your friends have like more than 100K observations. It's very hard for them to do oversampling or synthesis. They have to do downsampling, but they cannot. Otherwise, they cannot use their own PC. For some of you, you don't have encoding because all of the variables are numeric variables. So that part is extra. Again, this workflow has some extra sections that are not necessary for each project. And again, because you want also compete for getting internship from Siemens, I also recommend to use some. First of all, Tableau is much better for visualizations, but for the competition purposes, use visualization nodes inside Knime, okay? Generally speaking, in the job market, Tableau and Power BI are much better visualization tools, but for the competition, you can do self-learning and do visualization. So I'll go back to your friend's question about everybody use this workflow for the final project. Maybe you can use, but I don't guarantee if you win the competition or even get a good grade, because for each project, you need to do your own tuning. Okay, let's finalize this section and we have a break. Then I go to other parts of the workflow. So let's look at the oversampling here. So I use two row filter. Let's check the upper one. What it does, it check the loan status variable and only pick the rejection, right? You can see that your data set here is 24,499, okay? Every observation in here got rejected for the loan. We don't have to do anything here because we already we want to do oversampling. So what happens? Basically, I didn't do anything here. I just merged concatenated later on with the category that I had less number of observations. So I just for this part, which is our upper branch, which is for rejection, I just didn't do anything. I just kept it for future. With the group by, I just check what I have there. So if you see in the group by, this is loan status 0 means rejection, which is more than 24,000 observations. Okay, now we did the actual work in the lower branch. So check the next row filter. I checked and only select the values are 1, means only the people who got accepted for the loan. And check the group by here. 7,000 cases, which is much less than 24,499. Now, I want to do random oversampling, which means I use a node to copy paste multiple rows randomly. I did it with bootstrap sampling. Just go to the settings of this node. I said, and then I want 24,499 observations and with the random seed of 148. Again, because I want everyone to get exactly the same thing. After running this node, check the group by. Now, even for the accepted loan, I have 24,499 cases. So oversampling, right? Question? accepted. So accepted case here, check the first group by 7,000. Now, after oversampling, or here we call it bootstrap sampling, so 24,499. Pardon me?
There's going to be change, right? Like 24,000, people still think we're not doing the loan, like 7,000.
Yes. So what happens, you just copy paste some rows randomly. Maybe for one, so check, you can check the bootstrap sampling and see for some row ID, copy. And the copy paste is totally random.
So are you saying that that's not the right thing to use?
It's a good thing to do. But it's not, first of all, look here, I proposed 3 different approach for balancing the sample to avoid bias. One was downsampling, one was oversampling, and one was synthesize. Maybe in your project, synthesize gives you better accuracy. Or maybe some project downsampling gives a better accuracy. There is no guarantee. So the overall approach in machine learning AI is search. We search for the best possible results. Here, I just use oversampling, but again, it may not even give you the best results. Eventually, in concatenate node, I concatenate both rejection and acceptances. So if you go to the settings, I just do the union and create a new table. Let's check the group by, because group by gives you the overall statistics. Now, in both categories, I have same number of observations. Some of your friends today ask why we do this and that, right? So why we do normalization, why we do encoding. So just be clear, we are not doing statistics or mathematics. In statistics and mathematics, for everything you have you should provide the proof. In machine learning or AI, we do search. This approach may or may not give you the best results. We just check it. Maybe your final project, you do downsampling, gives you the better one, and you try oversampling and synthesize. Maybe you try all of them and just look at your results.
Yeah. 499 for accepted, not accepted. I mean, like it's like changing the whole status of the kind of like application again.
I mean, that's a very good question, Karafu. So he's saying that, look, you change the distribution of the actual data, right? Maybe you are not using the actual data set. So this is correct and not correct. So first of all, go back to what we had before this meta node. Look, before class imbalance, I did partitioning. So I partition my data in the train and test. I didn't do anything with the test set. I just did on the train set. So when you do prediction, you should do prediction on actual data. You cannot predict the synthesized data or oversampled data. So with the train section, I can do whatever I would like, as long as I have a good result on the test set. Again, you might say, why we do that? There is no mathematical reason for that. So with the train set, we do everything, we train whatever we want, and we just see if on the test set we have a good results or not. You might later on, if your accuracy is bad, you might say you change the train set, but in the actual distribution of the data, you couldn't have a very good results. You might say, okay, that was not a good thing. So you can do whatever you want on the train set, as long as in the test set you have a good result. How? We just search for different approaches. Okay. Again, let me go inside the imbalance one. After concatenating the tables, I do just random shuffling. I just, let's say, do a It's like have you play a card game, right? So you shuffle. So just shuffling the observations order. And that's it. So after class imbalance method, note we do the remaining part, which is first we do feature selection to avoid overfitting, and then train and clusterization. Let's have a break for now. You can have 15 minutes break, or but if you leave the class, please come back in 15 minutes. The next part of the class, we check the remaining part of this project. So it's a very exact, but you will see.
Sorry?
I'll see. You will see that, but it is a red even and the semester is
Coming. So like I can just like go through and discuss with you.
I have on Monday and Wednesday.
And Wednesday would be good.
Okay. Check if it's booked or not. If it's booked, we'll do it.
Thank you.
So this is interesting because I'm on the board of a bank. And when the auditors, from the government, we look to see, and so we do all kinds of samples.
Oh, I'm happy you like the technique.
The organization, and then the auditors come and they do the same thing. We've already done it internally, our IT folks. We've already run the data to make sure that there's nothing happening that is biasing who we're giving loans to.
You know what? You can ask your IT to give you a notification free one, and in order to do it, you don't have to know coding or programming.
Right,
You just
right.
drag and drop. And
Yeah, they may already, and I don't know the guts of what they do, but they may already do that. I don't know. But it's so interesting to see teaching it, but it's actually real. I mean, this happens in organizations. And then when the auditors from the government come on every year, they run models as well because they are checking to make sure we're not biased in what we're doing.
Can I be nosy a little bit?
Yes.
So since last year, after 2 years or 9 years, I tried to have darker outfit with thinner. But what about you? It's just for fashion or it's something?
What's that?
With me, my jacket. Your shirt and trousers are like black.
Oh, I guess what I have to block it.
Oh, okay. For me, it's for me.
Make them thinner. That's actually another tactic too.
You don't have to actually. I have to.
Not here anymore so much. So I got rid of it. I looked at my closet and said, I don't actually have a shirt.
You're donated a lot.
I did. I went to a place that I donated. Hundreds of pieces. It's ridiculous. And then if I look at my closet, it's like nothing left. There's still a lot of stuff. So yeah.
Well, I'm glad it's not for any event, just for fashion.
Yeah, yeah. Yeah. Just quickly put together something to put on to come out. So I don't come out here very often anymore. So how are you? Yeah, good. So you're up.
Next.
Right, so that's why. Because now there's a requirement for 2 visits. It has to be one a year before the packet visit. So to do you and Will and Faye.
Yeah, all of us makes sense. I'm not sure, but is it like starting fall and the judgment is in the spring, right?
I think so.
Okay.
Yeah, because he just found out.
I know.
So that was exciting. So, and then she's actually, today's her last day of classes. She's having her baby.
Yeah.
You know, she's she's like this. I don't know if she drove. I don't know. I should have contacted her. I could have driven her out. She lives near me. So, yeah. So I'm supposed to see her over the weekend before she goes.
Maybe it shouldn't be that far, but
40 minutes.
I think after Natick, there is a high traffic.
It's not so bad, you're right. After that, it gets, that exit gets really bad. Yeah. So are you still in Shrewsbury?
No, actually, I'm the most, there's like Kinsey lady. I used to do the Shrewsbury side now and there.
Oh, okay. Did you buy a house? Or?
On that year, so we had even 3 accident offer what we took from the contract. One for was like one of the we tried multiple houses. So one was a drug dealer, one of the tenants. Another one, it was failing the inspection because of termite. The third one, believe me or not, it was because like there is a misunderstanding in the will because it was for they wanted to sell their parents' house, which some of them like didn't like that. So even after acceptance, they called us that said we are not happy with the contract, and ask even if you get the house, you will see some problems with it. I said, okay, come on, just
Oh, that's too bad. Oh, right.
it's so we put like offer for 10, not 10, like 7, 8. 3 of them got accepted, but now I'm a strong. She's doing well. She tried to like she was accepting like business at Bosch, St. Louis, but she couldn't continue that because of like they said she must take courses in person. The professor was okay if she do research and meet her once a month, but the university didn't accept. Then now we are trying to get her into a game design program here, but they are very mean. Right? The President PTM, President Jordan said yes, but the dean of game design doesn't want to. He's listening. Like,
I don't even know.
yeah. I'm just what kind of because we even talk like Jordan said, if someone's like a faculty or staff wife wants to be here, I let them even I don't charge them for tuition. I talked with the computer science, they said we do same. Game design is just trying to find some good ways to avoid us. And it's just babyish. Even one time he said, okay, I'm okay with that, but HR may not think that like for my like staff. And I talked to Jordan, do you think I'm a baby? So it's like a dean say yes, and one of the staff saying no, and he said no. Even Dr. Fitton said tell his name is Paul something. Yeah, Paul. He said that okay, I said yes, but tell Dean Jordan talk to that dean because I want to do it through the deans, not you talk them directly. Right. Dr. David Jordan meet that dean, and he already knew that Dr. Fitton said, okay, do something for my wife, but he was like trying. He's a mean guy, but he tried to avoid us in a professional way, which everybody knew that he's like,
It's too bad because then it wouldn't be comfortable for her too.
I mean, professor didn't love her. Even they told her to be there to audit the classes. But Romana wants, she already had a job in North Carolina. Brought her here, and she already studied game design there. I would say, okay, auditing is fine, but she wants to get the job. Let's see. Yeah, she's. Yeah, luckiest guy. She's doing some like online or over the phone things like constantly, but it's just like she wants to see people in person. Not
Oh, right.
just, hey, hey, hey.
Hopefully. A lot of things going on.
Yeah.
After the spring.
Yeah, I wish my benefit was this year because we could move to San Luis for semester and she could take more courses, but like,
Could they defer it until next year?
uh, they said no, but if you push hard, they may accept it. Let's see.
Yeah,
But I think I'm the reason for Romanos failure. So
No, circumstances, nothing that you did. You're doing everything right. So, yeah. So is the rest of the class the same kind of thing going through the model?
yeah, frankly speaking, I'm not sure. Generally speaking, based on your education, I think you didn't do any programming for right?
Just very early.
They are exact same as you, almost
Yeah.
most of them.
Okay.
This is 70-80% don't have programming background.
Yeah, well, I mean, I could see, I mean, if you're in their shoulders, if they're free, but I could follow exactly what you were saying,
Oh.
why things are happening, you know, why you're doing what you're doing, it all makes sense.
Thank you.
So, it's maybe because now I can apply things, which when I was a student, I couldn't, right? So it was a lot harder in the abstract. But I could say, oh, okay, now I see why you.
Like half of them are MSc, so they have programming background. Half of them are like marketing, management.
Oh, right. So in the analytics in those fields, like marketing analytics.
They heard about things, but they didn't do coding.
Yeah, because they'll never have, they just have to understand what's going on in the background to make sure that what they're looking at is good information. I mean, that's really what it is. They do need to understand.
Because, like later when they get a job, they should communicate with MSBA guys. So it's the reason they learn this class, so they will understand the overall process, how it works, and to be able to communicate.
Well, the good, yes, the good MSBA folks will be able to do that, to really explain and present it. Such that you can utilize it, right? So that's what hopefully you, so that's hard. It's very different.
Hi, Knime. Good students, I like you.
So you're doing the same things?
So then
All right, well, let me get back to it.
okay.
And I'll write something up, I'll send it to you, so you see it before I send it to the official, because if I've got anything wrong, you have to let me know. Okay. All right.
Yeah.